Okay, Chapter 7, Frappy. Always make sure that you're showing your work, or they'll use free response AP problem practices. Um, so here our setup is quite straightforward. We have a large high school, right, concerned with the number of absences. Alright, principal prints a list showing the number of absences for each of the 2,500 students, so that's the size of our population. So we can go ahead and notate that as big N. Our population is 2,500. Okay. For this population, the distribution is skewed to the right. That's important. We are skewed to the right, and we have a mean, and we have a standard deviation. Okay. Random sample of 50 students. Alright, so our sample size little n equals 50, and we have that. Okay. So what is the shape of the sampling distribution of the sample mean? And explain. Right? So our sampling distribution, or our sample mean, we know is going to be approximately normally distributed with a mu based on the population and a standard deviation based on the population all over the square root of the sample size. Why? Because of the central limit theorem. Right? Because of the central limit theorem, okay, where we have our sample size n equals 50 is greater than or equal to 30. Right? And note that we also have, our sample size is less than or equal to 10% of our population, right? That 50 is less than or equal to 10% of 2,500, right? And we also have random selection, okay? So the approximately normal comes from our central limit theorem. The sample size issues is for our standard deviation. Random selection we always need to have. Okay, so that's the shape of our sampling distribution. All right. Now, why don't we pause the video for a moment and see if you can answer part B. Okay. So in part B, what are the mean and standard deviation of the sampling distribution? Well, we already stated that in part A above. All right, that mu sub x bar, the mean of the standard deviation of the sampling distribution, the mean of the sampling distribution, mu of x bar, is the same as mu sub x, which is 1.1. Okay. And we also know that sigma of x bar is equal to sigma x all over the square root of n, which is 1.4 divided by the square root of 50, which is approximately 0.198. Okay, and once again, note that this is because our sample size is less than or equal to 10% of our population size. Okay, it's important that the 10% condition on a sample mean must be met in order for us to use this. The central limit theorem must be met for us to use this. Always have random selection. Okay. Let's go ahead and pause the video for a bit and see if you can use that information to answer part C. So the probability that the mean number of absences in a random sample of 50 students is less than 1, okay, well, if we write out this notation, we know that we're being asked the probability that the mean number of absences in a random sample of 50 is less than 1. We do always need to calculate a z-score, and we always need to show the calculation. So we have 1 minus 1.1 all over 0.198, because we know it is x bar minus mu all over sigma over root n for these particular situations, right? And that value happens to be negative 0.51. So Therefore, I'm looking for the probability that my z-score is less than negative 0.51. If I use my table of values, or I use my calculator, right, push this in, and I get 0.30, Okay, so about a 30% chance of this happening. All right. So far, what have we done? Our shape is based on the central limit theorem and random selection, use of our sampling distribution mean and sampling distribution standard deviation based on the 10% condition, right? And then once I have that information, I can come over here and use these probabilities, okay? And then read over part D, pause the video, and unpause when you want to check your answer. Okay, so for this last portion, we know that the distribution is skewed. Okay, the principal is considering using the median number of absences rather than the mean because of that skewness, and so we'll come over here and say, hey, how could they use the simulation to estimate the standard deviation? All right, well, for that, you're just going to, for a simulation, take many samples. Take many samples. I'm going to take many samples and calculate the median of each sample. Okay. Then, once we have the median of each sample, then we will calculate the standard deviation of the sample medians. Okay. That will give us an estimate for the standard deviation of the sampling distribution of the sample median for sample sizes of size 50. And over here we do need to specify that. Many samples of size n equals 50. We need to specify that context. We're going to take many samples of size n equals 50 and calculate the median of each sample, then calculate the standard deviation of those sample medians. Okay? Hopefully that refreshes what you need to know for Chapter 7.